Winnebago partnered with Group 4 of Iowa State University's IMSE Capstone Team Fall 2024 to develop time standards and a model configurator for assembly standard labor. Located in Forest City, Iowa, Winnebago produces a wide variety of motorhomes. For these motorhomes, their industrial engineering team needed updated standards and a streamlined method for analyzing their labor data. The scope of this project centered around the door and drawer assembly processes on Line 3, which manufactures Class C motorhomes. Winnebago intends to use the tools from this project as a benchmark for their other production lines as well. The team had three major objectives. 1. To perform time studies and deliver time standard estimates for 4 drawer and 5 door configurations across all 15 models produced on Line 3. 2. To create a streamlined time study tool to automate the time observation process and save the engineering team 20% on future collection times. And 3. To build a configuration and reporting tool that can estimate labor hours in less than 1 minute, as well as assist in production scheduling, line balancing, and continuous improvement. Now to hand it off to Ashley.
Thanks, Jeremiah. Over the course of our time study collection, our team collected 367 data points, equivalent to 11.6 hours. Our team goal was to gather 5 or more observations on each configuration type. With this goal, we were able to define normal time versus estimated time, dependent on how many times observes were made on each task. Moving forward, this shows the systematic flow of data through the multi-layer configuration tool that our team developed through Excel. The configurator pulls the data described on the previous slide and can be used to automatically generate standard labor reports. Now Lochlan will provide a demonstration of how the tool functions.
Thanks, Ashley. So for the first page of the configurator you're directed to will be this standardized configuration page. This page allows the IEs at Winnebago to enter every task they're looking to time study in a standardized format, allowing for the easy manipulation of data throughout the configuration tool. The next page of note is the data collection tool, where each instance of the task being studied will be recorded in the data collection so that it can then be pulled into the task lookup page. The task lookup page goes through each task analyzed, developing the time standard and establishing it for the task, and then referencing it by each model. For example, for the 322Ms, the backsocket standard task has 8 instances for each model recorded. This then allows us to calculate the standard labor, allowing the Winnebago team to perform any analysis they might need to do. Ultimately, the task lookup page pulls into the report page, which allows the Winnebago team to generate reports used for standard labor, production scheduling, or any other forms of analysis they might need to do on a daily basis. An example of how this works is we can input whichever models we're interested in studying for that day, generate the report, and Excel will automatically spit out the standard labor allocation for each station and each department for every model specified. The ultimate goal is to establish standard labor and time standards across the entire business unit of Winnebago so that the engineering team and the management team can perform any analysis they might need to make data-driven decisions. Next, I'll pass it over to Zach, who will go over the ROI and some final thoughts.
Thank you, Lochlan. So moving into our return on investment, we have an indirect return through labor productivity increase. This is based on our assumption that the process of generating a detailed report on each vehicle moving through the line on any given day and the labor requirements for that vehicle would take 20 minutes per day of Winnebago engineers' time. We've saved Winnebago a total of 335 hours just across line 3. We also have a direct return, which is a projected increase of 0.25% productivity across all lines. This is a number that Winnebago projected, and this leads to a return of $690,000. These two together lead to a direct and indirect return on investment of $703,389 over the next 3 years. We want to thank Winnebago and the engineers and operators there for giving us as a team the opportunity to work on this capstone project. And we want to thank Dr. Sly and the IMSE department at Iowa State as well. And we want to thank you for taking the time to watch this video and learn about industrial engineering capstone. Thank you.